I've drawn here an XY grid, or if you like to think about it differently, an R theta grid. Remember, we have two coordinate systems now. We have XY coordinates, and we have polar coordinates. And what we need to do is establish some equations that help us change back and forth between one coordinate system and the other. And I want to remind you that you already know this stuff. This is just SOHCAHTOA, basically. I'm not simplifying either. SOHCAHTOA will help you through just about everything you need here. And let's see how. Let's imagine the sine of that angle theta. And if you remember opposite over hypotenuse, what does that refer to? The opposite of that angle is right here. That's the y value. And the hypotenuse is what I've called r. It's the distance from the origin to that point we're interested in. So sine of theta equals y over r. Well, let's rearrange that a little bit. I'm going to multiply each side by r. R times sine of theta equals y. That is a critical equation for us. There's going to be 4 equations total. And you can see that one right here. So here's y, and here is r sine of theta. Same idea. Let's just do it with cosine. Cosine theta equals adjacent over hypotenuse. Rearrange that a little bit, and we have r cosine theta equals x. So that's this guy right here. Now, if you imagine, it's pretty good for SOHCAHTOA. I don't think we're done yet. I think there's one more SOHCAHTOA thing that's going to come in handy. And that is tangent of theta. There's the TOA part. Opposite, that's y over adjacent. That's x. Rearrange, we don't even need to rearrange that. There it is, we're done. Tangent of theta equals y over x. So that's this guy right here. And what's left? Well, you may recognize this as the Pythagorean identity, right? X squared plus y squared equals r squared, or hypotenuse squared. Now, where these come in handy is in 2 ways. Switching rectangular coordinates to polar coordinates, or rectangular equations to polar equations. And we're going to get some practice doing both coming up.